Hello students, I am Dr. Rajaram Dhok from Savitribai Phule Pune University affiliated Agricultural Development Trust Shardabai Pawar Mahila College Sharda Nagar Baramati. Let's start. Today we learn about the Werner's theory. So in the first lecture of Werner's theory, we discuss about postulates of Werner's theory. So in this Werner's theory, we firstly see some basic introduction about the Werner theory. So Werner is one of the scientists and he put forth his theory about the coordination complexes in 1893, and at that time Werner have age 26, and at that very smaller age he proposed his theory for the formation of coordination complexes. In the coordination compounds, the number or bonds formed by the central metal atom is greater than that expected from the usual valency consideration, that is called the coordinate compounds. And such type of coordinate compounds are very important compounds, and firstly it is proposed by the Werner, and this theory is introduced by the Werner firstly. So Werner introduced the concepts of auxiliary valencies. So that Werner have studied different compounds. Out of that, some of the compounds studied by Werner we discuss here, and in that one important compound is COCl3 and 6NH3. So that Werner taken the cobalt chloride, and in that cobalt chloride he added the ammonia, and from that he prepared the compound that is CONH36Cl3. Then one of the other examples studied by the Werner, that is FeCN2 and 4KCN. So that FeCN2 and 4KCN, that when mixed, then from that the coordinate complex is formed, and with that coordinate complex he studied the different postulates, and from that he confirmed that is the coordinate complex. Then one of the example he studied is PtCl4 and ammonia. So when ammonia is added in the platinum chloride, then from that the coordinate complex is formed. And for the study of this coordination chemistry, Werner got the Nobel Prize in chemistry in 1913. So we see the different postulates which is shown by Werner. So mainly Werner gives certain postulates. So we see that all the postulates one by one by using the suitable examples. So first postulates or basic postulates explained by the Werner is valency of the coordinate complexes. So most of the metal shows two types of valencies. It is first postulates explained by the Werner. So which two types of valencies present? He showed that there are primary valency, or that primary valency that is also called as ionizable valency. And this ionizable valency is corresponds to the oxidation number of that metal. So that Werner have explained, he have proved that in the coordinate complexes there is primary or ionizable valency, and that valency is equivalent to the oxidation number of that metal which is present in that coordinate complex. Then secondary valency present in the coordinate complex, that is the secondary valency, or that secondary valency that is also called as non-ionizable valency. And these secondary valency that corresponds to the coordination number of metal. Means if that metal is attached with 6 ligands, then coordination number of that metal is 6 and secondary valency of that metal is 6. In case of the metal, that metal has primary valency plus 3. Means that metal have oxidation number plus 3, and to balance that plus 3 charge, it acquires that primary valency or plus 3. So in this way, the first postulates, that is the primary valency and secondary valency, these are explained by the Werner, and for that purpose he have taken different examples and proved that primary and secondary both valencies are satisfied by that example. And if that example, if that coordinate compound satisfies both the valencies, then that compound is called as coordinate complex according to the Werner theory. Now, when these valencies are shown, then how they are shown? And for that purpose, they showed that primary valency which is satisfied by that metal and secondary valency which is satisfied that metal, when they are attached with the metal, then how they are attached. So primary valencies of that elements are satisfied by negative ions. Means these ions are attached to the central metal atom, and generally they are negatively charged, and that negatively charged ions satisfies the positive charge of the metal. Means we take example Fe plus 3, metal is present, then that metal is attached with some other ions which is negatively charged and it carries minus 3 charge. Means in that metal satisfies primary valency, but it is only for balancing the charge, it is not balance the coordination number, and so these valencies are attached to the metal and it is shown by the dotted lines. Because it is not directly attached, it is indirectly attached, it is for balancing the charge of that metal. Then secondary valencies of that elements or of that metals, they are satisfied by negative ions or by group of ions or by neutral molecules like H2O, amine or any other, or sometimes some positive ions. And when that secondary valencies are attached to the metals, then they are directly attached. Metal and secondary valency means simply say that the ligands, they are attached with each other directly, and it is shown by thick lines. It is shown by thick lines. So in this way, that primary valency and secondary valency when attached with the metal, then the secondary valencies is shown by the thick line, while primary valencies shown by the dotted lines because it is indirectly attached. So these both valencies are fulfilled by that coordinate complexes, and they are attached such type of numbers to that metal. Now we see one of the points that is explained by that Werner, and he shows that every element possesses a fixed number of secondary valency. So this secondary valency is the equivalent to coordination number of that metal. So just we have taken the example of Fe, like that we take the example of copper. So copper, they have coordination number 4. And when that copper is attached with Cn, then 4 Cn is attached to the copper and it forms complex. If we see the cobalt, then cobalt has coordination number 6. Fe has coordination number 6. And so Fe is attached with 6 ligand, cobalt is attached with 6 ligand. So secondary valency is fixed. And these secondary valencies are attached to the central metal atom and they are attached in certain directions. So our 4 point, that when primary valency, secondary valency, they are attached, then they acquire certain positions. So the coordinated groups or coordination valency, they are firmly held to the central atom, while the other atoms are not firmly. Means this secondary valency are firmly attached. It is directly attached. But primary valencies are not directly attached. It is indirectly attached. And for that purpose, again, we take one example, that is potassium ferrocyanide, K4Fe6. In that K4Fe6, these 6 ions are attached directly to the Fe because it is secondary valency, and in the structure, it is shown by thick line. But K, when attached with Fe, then it is indirectly attached and it is shown by the dotted line. Then one of the other points, that is secondary valencies are directed in definite directions in the space about the central atom or ion. Means at the center there is metal and around that ligands are attached. So when that ligands are attached, then that ligands are attached in particular direction. For example, Fe is central metal and that Fe is attached with 6 Cn. Then how that 6 Cns are attached? So there are 6 Cns, means that 6 Cns are attached at 6 corners of octahedron. Means 4 are in the plane of square and 2 are in the pyramidal position, axial position. And so there is formation of square planar bipyramidal structure or octahedral structure. Means that 6 ligands are attached at 6 corners of octahedron. If there are coordination number 4, then that 4 ligands are attached at 4 corners of square, or that may be at the tetrahedral position. So in this way, that secondary valencies are attached at the particular direction in the space, and so these secondary valencies are responsible for the geometrical shape.